Hey class, welcome to our first space science lesson. I'm always excited about learning about space and teaching you guys about space. Hopefully you guys are getting excited about it as well. Um, this will be our first lesson. I'll be doing a couple of these slideshows as we go through, and hopefully it works out well. Please let me know if there's anything I can change or make easier for you guys. So let's begin. Wow, that's taking a long time. All right, here we go. Space, how big and how far? That will be the name of our first space science unit. That will be the name that you put on your Google document. Here are the instructions for that. You're going to open up a new doc in a new tab. Title it Space, How Big and How Far. Remember, you can pause the video at any time to add to your notebook. You can press pause anytime. I'm going to be telling you a few times when you should pause and you should add this to your notebook. Really quick, just like I have a tab open right here, you can have this going right there. Man, my computer's taking a long time to load. There we go. So I titled it up here, Space, How Big and How Far. I would like you to add your name to it as well. So I would put my name, Mr. Huddleston, here. So you would put your name in there as well. And then this is lesson 1, and the day's date is April 20th, 2020. And then you can add right below there, and you can switch back and forth. Okay. Whoop. Back to the presentation. If you need to do that now, press pause and make sure you have a document ready to go for everything after this. All right, I want you to take a look at this picture. And I want you to think about what you see. Go ahead and press pause. All right, if you've unpaused, hopefully you see, it looks like a man, a coffee table with some cups of tea or coffee, and a lounge chair and a ball. So we're going to press play and see what happens. All right, if you need to, you can go back and look at that video again. You might be wondering, why on earth did I just show you that quirky video with different sized objects? Well, a lot about what we learn in space science is going to be about how different objects can appear different sizes to us depending on a perspective of how far we are away from those objects. That's what this is going to be all about, and we're going to come back to this a little bit later. So, well, let's get my face out of the way there. So one thing to take away today is there is a lot of space in space. There's just so much space, it's hard to even imagine, it's hard to even picture. So in our slideshow, we're going to be learning about the size and scale of objects in space. We will look into the Earth's place in the universe and just how big and far things are in space. So really just how the vastness of space, it's really hard to imagine, but we have the help of scale models to do that. So here's the first thing you're going to add to your notebook for lesson 1. And go ahead and once I read these, you can pause and work on this. And this is before you've learned anything, and it's okay if you don't know much. So these are the 3 things you're going to write down what you know. How big is the sun and the moon compared to the Earth? So do you think they are the same size? Is the moon smaller than the Earth? Is the sun bigger than the moon? Are the sun and the moon the same size? Just put really quick what you think. And like, this one's bigger than that one. The Earth is bigger than the sun and the moon, or so on. Whatever you think. I'm not going to tell you yet, So just put down what you think for now. And you don't have to write a ton. Just boom, 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 how big you think they are. Does the sun circle the Earth, or does the Earth circle the sun? I want you to pick one of those two on what you believe. Do you think that the Earth orbits around the sun, or that the sun orbits the Earth, as when we see the sunset at night and the sunrise in the morning? And then finally, which is closer to the Earth, the sun or the moon? Which object is closer to the Earth? So go ahead and press pause and answer these 3 questions in your document. All right. If you're pressing play, we're going to move on. So in space, we use lots of models. We've used this term models in science all the time. We use 3D models, like a model of the solar system you can see here, and a model of the Saturn V rocket using Legos to build models. That's one of my favorite things to do. This is the rocket that we have in our classroom. We also use two-dimensional models, or 2D models, which are drawings and illustrations. So right here we've got a drawing of the solar system. And then we also use math models. You're using math models in math. That helps us visualize, that helps us solve the math problem, it helps us explain the math problems. All these types of models are used in science, and especially in space science, because in space it's really hard to visualize just how big and far these things are. So we have to create models of them. It's not like if you were studying trees and you could walk outside and go investigate a tree. Well, very few people can go to space. It's very hard to get to space. You have to be specially trained for that. So space scientists use models all the time. So these are the types of models we use in science: 3D, 2D, and math models. Go ahead and pause and put those 3 examples of models in your notebook now: 3D, 2D, and math. So in science, we use models to help us understand things that may be too big or too far to visualize in real life, like the sun, the moon, other planets, other stars, other galaxies, everything. It's just too big and too far. It's important to remember that models are accurate in some ways and inaccurate in other ways. We're going to be using those words a lot: accurate and inaccurate. So you need to put these vocab words in your notebook. Go ahead and press pause and write these down in your notebook now. All right. You should have accurate is correct. It is something that is correct or very close to being correct. Inaccurate is the opposite of that. It means it's not accurate. It's wrong. It's not correct. You need to have these vocabs in your document. So, for example, one of the classic models is something like a Hot Wheel car. We have the picture of a scale model of a car. And I want you to think about ways that it is, move my face real quick, ways that it is accurate and inaccurate to a real car. So go ahead and press pause and think about ways it is accurate and inaccurate now. Okay? So hopefully you paused and thought about that. Maybe you thought of a few things about how a model car, here's one example right here, is inaccurate and accurate. You might have that. Well, it's about the same shape of a car. It is made out of metal like a car. It has windows. It has an engine, but maybe it doesn't have an engine that works. I don't think there's gas inside a Hot Wheel car. So that's not completely accurate. It's also, the wheels aren't made out of rubber. They're made out of plastic. And their seats are made out of plastic too. So that's not quite accurate. It doesn't go on its own. It doesn't have an engine that drives it. You have to roll it on the floor. It could be accurate in that it looks a lot like a real car. Maybe it doesn't have real lights. It just has painted on lights. So there's lots of inaccuracies and accuracies to a model. You can never really just have a completely accurate model, right? It can't be completely accurate. So that's what we're going to do today, is we're going to look at some models of the solar system. We see these all the time. Here's 2 posters of the solar system. We've got one right here and one right here. Now, there are some accurate parts of the solar system, models you see here, and there's some inaccurate parts. So go ahead and press pause and think about what is accurate, what is correct about these models, and what is incorrect. Go ahead and press pause now and think about that. All right. So maybe you thought of a few things. Well, let's start with what's accurate. The order is accurate. I'm not putting in models that are going to trick you. These both have orders. It has going from the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. If it's an older model, it might have Pluto on there too. We'll talk about that later. So the order is correct. Okay. This one has more of a cartoony picture. So maybe that's a bit of an inaccuracy. And this one has more photographic realism. So a bit more accurate with that. You might think about the inaccuracies in the size of them. The size between the planets are comparable. Here the sizes are all over this place. And we look at the size of the sun. We'll find out later if that sun is actually a realistic comparison to the planets out here. We see these lines here. Those lines don't exist in real life, but it shows you the orbit of the planets going around the sun. Now, right here, it shows them in a straight line. Now, we always see these models of them in a straight line. We can imagine the planets out there in a straight line. They are never lined up perfectly like that, ever. That's what this more cartoonish model is trying to show you, that they could be in different places at different time while they're orbiting the sun. So that's an inaccuracy there. That's the point of models, is sometimes there's ways they can show you. It shows us the pattern. The order of the planets really easy. It shows us kind of how they look, but they're never lined up like that. So that's a big inaccuracy with these, and how close they are. Think about the distances between these planets. We can't fit them on a poster like that. They're so far, and to have that shape. And we're going to look at a couple videos that show that and just how hard it is to have a scale model of the solar system. All right. Today you're going to look at what's accurate and inaccurate. So you're going to go to the Google Classroom page and open up the document Space Science Models. I'll have that document open. You're going to pick 2 solar system models. You're going to copy and paste them in your, well, not your digital science notebook anymore, but you're going to copy and paste them in that document we just made. Now you will compare and contrast them. How are they alike? How are they similar? And let's go back. And how are they different? Compare and contrast. How are they alike and how are they different? In what ways are they accurate and inaccurate? Okay, we're going to pause there for lesson 1. Remember to email me questions or ask in the Google Classroom. And really quick, I'm going to show you what that looks like. When you go to the Google Classroom, you're going to open up this document called Space Science Models. And we're going to wait here forever for it to load. And there we go. We've got some of the ones we saw on my slideshow today, as well as a few others. And you can pick 2 of these, and you're going to compare and contrast them. Remember, you can copy and paste. Click on it so it's selected. You see how the little blue goes around the rectangle there, and you can left click or push 2 fingers down on your touchpad, copy, and then you're going to put that into your lesson here. Yours will have more writing than mine, obviously, right now. And you can resize that so you have more room for writing, whatever you need. And you can pick the other one, and you're going to compare and contrast these. How are they different? What do they show that's different? And how are they similar? Just kind of like what I just did in the slideshow. All right, guys, that's it for now. Have fun. Stay tuned for more.